Rheem Hybrid water heater. It's a Generation 5, and it utilizes a heat pump up on top and electric elements on the bottom. So we got a heat pump on top. We've got what equates to basically a standard electric water heater down on the bottom. And I want to just review some of the easier things you can use to troubleshoot the water heater, gather a little bit of information, and then try and figure out which direction you want to go with troubleshooting if you're having some sort of a problem with the water heater, whether it be no hot water at all, or if it is a situation where you have some hot water but not enough hot water, or running out of hot water. So let's talk about that. Okay, now on our model here, we've got the screen lit up. It's showing that it's in a heat pump mode. Temperature set at 120. It's currently in standby mode. It's not calling for heat. But if you have a unit and you're needing to check the power, make sure you have proper voltage. A good place to do that is either at the top of the water heater or at your disconnect box. You can open up your disconnect box or the plug if it's plugged into the wall, and you can test right there. Okay, let's just do a quick test up here. We'll start at the top, work our way down. Okay, so we can pull our top connection off and expose the two wire nuts that are in there. That's a great place to test from. You'll want to get your multimeter out and set that to alternating current. This is an auto ranging meter. If yours is not auto ranging, just set it to the one step higher than what you're testing. We're looking for 240 here. 208 to 240 is of course going to be what works for this heater. So if your meter has an option for 500 or 700, that's what you would set it at, not at 200. That would be too low. All right. One probe in one side and one in the other. Let me just try and do this here with two hands. If you don't have it connected in there properly, you might get some weird numbers. So you want to try and make sure you get a good connection. You can get a good reading. 242.6. That's good. So we know we've got good voltage to the top of the heater. Now we can go ahead and put this back together. Oh, let me add this real quick. Also, the CTA box that's up here sometimes gets hooked up, sometimes it doesn't. It depends on if you're going to utilize this or not. If you're not sure, you can leave it disconnected. There's two wires down in there, one red, one black. You can't really see them. There's a red and a black wire. If you want to hook that up, you can simply wire those directly into here, red to red, black to black. And if you don't use it, it's fine. If you do use it, it's hooked up and ready to go. Okay, let's talk about some troubleshooting steps. Okay, if we're dealing with a situation with not enough hot water or water not hot enough, we might want to look at the display and see what the temperature is set at. This one says 120 and it's not calling for heat, which leads me to believe the water heater would have 120 degree water in it, or at least it thinks it does. So, easy way to verify that, and this is of course just going to be a touch verification. We're going to run some water through the TMP. That's really hot. It's almost too hot to touch for a few seconds. That's going to be pretty close to 120. Now, if I've got water coming out of my faucet that's not very hot, and I'll be able to tell if it's hotter than this or cooler. If it's not hot enough coming out of the faucet, I'm going to look at possibly a crossover connection or maybe a bad cartridge in a faucet that's allowing cold water to bleed over. Okay, let's move on to another scenario. If your heat pump water heater appears to be running all of the time, and by running all of the time, I mean heat pump going, and you're in an energy saver or high demand mode, meaning the elements will be utilized, we're going to start to look at where that heat's going, okay? If we know the water to be heating and it's not coming out warm or hot at the faucet, continuously running, it's an easy test we can do, and that's by shutting off the incoming water. Every water heater should have an on and off valve. This one is just back here. And I can shut that off like that. That will create a condition in the water heater where no water is flowing through it. So now I'm going to stop the water flow. Let me wait about an hour and I'll see if this water heater can recover. Wait an hour, turn the water back on, see if it's hot. Now here's something you want to listen for. This water heater is off. There's no known leaks on this system. When I turn this valve back on, and if I was testing for a leak, I would wait a little bit longer. But for time savings, we're just going to do it now. I turn it back on. I did not hear any water movement, meaning there wasn't any water loss after that. If there's a leak in the system, you'll hear the noise pressurizing the system back up when you turn this valve back on. That's a good indication that water is running out somewhere, and you'll need to locate that leak. Now, if you do turn your water back on and you hear that noise and you suspect water's running out somewhere, well, easiest place to look, TMP. Do we have a pressure or a temperature problem? Has it worn this TMP valve out? Is it older than 3 years? Let's go to the outside of the house, wherever that runs out. We can look and see if there's water running there. Going around to all of the faucets also, easy check. Let's go see if we've got any water dripping on any faucets. Okay. Now, moving on from that, if we've done all of these tests and we suspect that there's just a problem with the heater, let's look at the data we can get from this unit and figure out what's going on. We're going to start at the top. Panel comes off, battery right here, memory backup. 2 screws. Two screws hold this user interface on. In the back is the main power that comes in along with your wiring harnesses. These wiring harnesses connect everything inside of the heater from the lower elements to all the sensors, your thermistors. Now, 2 key components right behind this user interface. 2 key components right behind this user interface. It's going to be your current sensing transformer, your current sensor right here, little round donut around the red wire. It's a black and white wire coming off of that, and it connects to this plug here. This is where you're going to test from. You would disconnect this and ohm it out. You should get about 30 ohms on this resistor. Hidden back over here is your capacitor. We want to test that. Different water heaters have different ranges. I think the range on this one's about 330 to 370-ish, plus or minus 10%. Water heater needs to be going, compressor and fan, to get a test on that. And while we're here, we'll go ahead and test these 2 components and see what they say. All right, we'll do the easy one first. I'm going to set that to ohms. I'm going to unplug this little guy here. There's 2 probes in there, 2 prongs I should say. You put your probes in there, just be gentle so you don't bend those up. Again, I'm going to try and do this with one hand and then show it. This water heater is not very old, it's new. That's a new sensor, 30.1. Hopefully you can see that there, 30. So we can call that good. Easy test. All right, now let's test the capacitor. We need to go into test mode. All right, so I've held the mode and test button down. It goes into TST. Upper element, lower element, compressor. Compressor kicks on. Like I said, the fan should also kick on. I can hear the compressor running. I can feel the air blowing off of the fan. right. Let's see what our capacitor says. Let's see if I can angle that so that you can see it. Okay, so you just test across the two connections on the top of the capacitor. There's 4 prongs on the left, 4 on the right. 315. This is a known voltage on this particular capacitor while it's running on the Generation 5. Most of the capacitors that are tested come up in this range. This one works just fine, so that's going to be good. That's within what our chart says, 10 to 20%, and we're looking good. Okay. So 315, let's call that good. Current sensor is good. Let's look at our numbers. I'm going to go ahead and put this back in place here. Careful not to pinch any wires. All right. Okay. We need to go back into test mode. We need to go up to compressor. Okay, back into test mode. Fan. Shut off valve. Oh, this thing just shut off. All right, we're gonna need to wait a minute to get it to come back on. There it goes. Okay. So real quick, we've got an ambient temperature of 89 degrees. Now I know that thermistor is working because I know it's about 90 degrees in here. So, what does that tell us? It tells us that if this evaporator is removing heat, that I should feel cool air coming through here. Cooler than 90, and I do. Current amp draw, we're gonna give this thing a minute to ramp up here. Okay, discharge temperature. Discharge temperature is what's gonna heat our water. It's at 115 degrees. Suction temperature is 86 degrees. So after that hot discharge temperature goes down and coils around the tank, it's going to be cooler coming back up because I've put that heat into the water. Coming back up at 86 degrees. Wait a minute for that pump compressor to come on, and it's running now. You can hear it come on. It sounds like a refrigerator or a freezer if you're standing next to it. It's not extremely noisy. If you have a real quiet space in your house, it doesn't mean there's anything wrong with the heater. Maybe you just don't like the noise. If you're sensitive to that sort of noise, consider relocating the heater. All right, now we're getting a good test here. We're seeing that the evaporator temp is going down. We're 90 degrees in here. This evaporator temperature is showing to be in the 60s now. That air is nice and cold. This is telling me what? That the ambient temperature is 90. The evaporator is removing heat from the air. Oh, well, I lost my test. Nope. I'm gonna leave all this in here because if you're trying to do this or you're trying to direct somebody to do this, this is frustrating. All right. Enter compressor. Let's see what we have. Discharge temps 122. We're trying to get our water to 120. That's definitely going to do it. Suction temp is 83. We got almost a 40-degree split between discharge and suction. And we've got our test going again. Ambient's going to remain the same because it's not getting any cooler in this garage. And we saw the suction temperature go down into the 60s. Those are good. I got hot coolant going down. I've got cooler coolant coming back up. Maybe I should say Freon, whatever you want to consider it. Nice and cool, pulling a lot of heat out of the air, sending it down into the water heater. Now, if we see numbers like that, we can suspect that this part is working. If it's running all of the time, there might be a demand issue. It could be an environment issue. We're sitting in 90-degree weather in a garage. This water heater works great out here. Okay, if we're in Seattle in the attic or a basement of a house where it's super cold, it's going to work a little bit harder. It may not even work at all. It may rely heavily on the elements. Let's talk about the elements. We're going to put this thing back together and we'll come out of test mode for now. We'll go in the test mode menu, which is just fine. Okay, let's look at these elements. All right, upper element first, 2 screws. Yep, we'll just let that fall to the ground. That won't hurt anything. Okay, careful, this is all live. Got this little plastic cover that comes right off. Here we have ECO, okay? Our thermistor is plugged in here. If you need to test your thermistor, unplug this. Use the ohm setting. All right. And let's see here. I want to show you something on this. We may go back into test mode because I forgot to mention one thing, and that is you can check the upper and lower temperatures on these thermistors. It'll tell you if you've got a problem as well. If your water's coming out hot, but the thermistor says it's not hot inside the tank, you likely have a sensor problem or a wiring problem. Okay, we're going to go to voltage, and we will have 240 volts at the top. 240 volts here. Nothing here. Okay. Now, if I test one screw, I get 120 volts. If I test the other screw, I get 120 volts. This screws people up a lot. Plumbers especially that haven't done this in a while or they're out of practice. Maybe somebody that's not too sure what they're doing. They'll measure a screw. They might start here, testing the 2 screws, go, well, I don't have any power. Let me see what I've got to ground. Well, I've got 120 here, and I've got 120 here. Huh. Well, 120 and 120 is 240, right? No, not with alternating current. I need to see the combined 240. This element is not activated right now. Okay? If it's activated, I'm going to touch each screw and I'm going to get a reading just like this. And the same is true for the bottom element. Okay? Only one of these will fire at a time. And you've got to make sure you've got proper voltage to the element. And that's by testing both screws, both connections, both wires up top would have been the same way. If I had a dead leg or a blown fuse or something, I could test one side and get 120 and then test the other side and get 120 and think that I'm good, think that I've got 240, but I don't. I have to do this. One on each screw, combined 240. That's what we want to see. Okay? Down at the bottom, the sensor plug is there. That's in another video where you can access the sensor for the water leak detector. And then also the thermistor. They're down there easily accessible. You can ohm those out Verify that you've got a good reading on those. If you're not getting a good reading, you can replace the thermistor, check the wiring. If you're not getting good readings up top on those thermistors, you can replace those thermistors as well. The idea is to see what the water heater thinks is going on versus what you know is going on, and that's basically temperatures. Okay, I've seen instances where not so much down here, elements will sometimes be grounded or blown, and that's in another video we have where you can see how to test an element by disconnecting power and removing the screws, and then you use the ohm meter to ohm it out and make sure that you've got good continuity and good resistance through the element. But on the thermistors up top, you'll see the system running. You might see some weird temperature. A lot of times what I see is you put your hand, you know it's ambient temperature, let's just make up a number, say it's 85. Compressor's running and that fan is blowing nice cool air, right? If it's 85 degrees, that fan could be blowing 65 degree air through there. And that heat exchanger could be at 65 degrees. Excuse me. But when you go into test mode, the sensor for the heat exchanger says 90 degrees or 85. It's matching the ambient. Or it could say 240 or negative 40, and that's just a problem right there. Boom, that thing gets replaced. But if it's giving you a temperature that doesn't make sense, got 65 degree air blowing out of the fan, and the heat exchanger temp is coming back at 85, well, we've got a problem. It's not reading correctly. Chances are if you took it out and put an ohm meter on it, it would not be within range. So you would be changing out thermistors. Okay, I'm gonna go ahead and put this back together. I hope that helped. I hope it had some good information in there for you. The key thing I want you to take away from this is to look at the information you get from the heater and compare that to your own testing. Okay, water temperature, water running in the system, that sort of stuff. Then look at your components, look at your temperatures, follow the troubleshooting steps, and you should be able to resolve any issue with this heater relatively easy.